do certain specific calculations, and they're always characterized by having some inputs and outputs. So this is a simple program that I wrote to get the mean and standard deviation of a vector x that's coming in, okay? So you have vector x over there. Notice you don't even have to tell what the length is, okay? We'll do that later in the program. And just as recall a definition of mean and standard deviation, right? Everyone knows those, okay? Now, one thing which I'm going to point out to you is that you have to be very careful when you use not just MATLAB, but any software program, because many times there are slight differences in the way people define something. And I actually found this out by mistake. Not but by basically by kind of, I did something and I got a different answer and I found out why it happened. And I'll kind of do that so you'll discover it the way I did. Okay, so we basically want to do these calculations, and there's only one input over here, the vector x, which has the data in it, okay? So clearly you're going to need this n, which is the number of elements in x, and there's a built-in program, there's a built-in function rather than MATLAB called length, and you give it an input argument, it'll tell you how many elements that thing has. It's a vector. If it's a matrix, I believe it tells you the number of rows. And if you have a matrix, there's another thing called size, S-I-Z-E, which will tell you the number of rows and columns, okay? And all this you can find, like I said, you go to this help thing, where is that? Oh yeah, up here. The search thing is very useful, and it's keyword sensitive, so you don't have to have the exact command. You can just put in something vague, and hopefully it'll zero in on what you want, okay? So we got the length of x in memory location n, okay? And you notice that every line over here I've terminated by a semicolon, because I don't want to see that really. The only thing I'm interested in is the final value, the mean and standard deviation. I want to store that someplace, so I don't want this thing to spit this out every time it goes through in all the intermediate calculations. Okay, so what's the mean now? Now the mean is, you can do it in a loop like that. You can actually put a for loop, as they say, and you can do it like that, but it's much easier, it's much more efficient to vectorize, and there's a command in MATLAB called sum. You should look it up, and what it does, if it's given a vector, it'll just sum the elements in that vector. So clearly sum contains the numerator, and I divide by n, boom, that's the thing for the mean, okay? Now standard deviation is a little more tricky. Let's look at the standard deviation as a mathematical formula. What do? You go to each data point, right? You subtract the mean, you square it, you add that, and then you divide by n, finally take the square root, okay? So we see in standard deviation, okay, the last line over there, we see the square root over there, and then there's a sum again, but let's look very carefully what we're doing over here. Instead of doing x1 minus the mean, x2 minus the mean, and stuff like that, I could do that in a shorthand way by doing the vector x minus the mean. And like I told you before, MATLAB assumes when you have a vector and you're subtracting off a scalar from it, it'll subtract off that scalar from every component of the vector. That's exactly what you want to do here. Now, when you do x vector minus mean, you get a vector. What do you want to do? You don't want to multiply that vector by itself. You want to square it element-wise. So you'll notice that right before the square operation is that dot, which tells us to do an operation element-wise, okay? Finally, divide by n and take the square root. Now, of course, it's very important that since the program is going to store the end result in mean and standard deviation, those exact words have to appear somewhere, okay? It doesn't matter what you called it. I could have called it M star or something and put this M star, okay? The names are immaterial, okay? But usually when you pick a name that's indicative of what goes on, and the order is very important, right? Okay? If you document the program where it's mean standard deviation, and then you basically call it the other way, you're going to get the two things, messed up. So which one you put first, mean or standard deviation, is immaterial, but of course you have to realize once it's established in the program, the first output argument is the mean, and the second one is the standard deviation. Okay. So what I'm going to do now is just run this thing on an arbitrary vector, okay? Let's take our vector, let's call it V, and there's a built-in called rand. Let's make it, I don't know, 1,000 by 1, a lot of data points. I'm not going to look at those. Rand, if you look at it, is a built-in function. It just generates randomly distributed numbers between 0 and 1, okay? There's a whole bunch of things with random numbers you can do in MATLAB, okay? Do who's on that. Of course, what do we have? Okay, that's weird. V. Okay, this seems very strange over here. I never seen that. Oh yeah, V, I must have hit something else. 1,000 by 1, okay. Now, let's use the program, okay? And again, just to show you the arguments are immaterial, the first output argument is the mean. In this program, I'll call it M1. I don't have to call it mean, the name is immaterial, right? I'll call the standard deviation S1, okay? And that equals stat of vector V, right? Should compute it now. And what do we get for the mean? We get a mean of 0.4888 and a standard deviation, I called it S1, right? Of 0.2831, okay. Now, as you can imagine, MATLAB has its own mean and standard deviation built in. If you look up over here, mean, average, it'll tell you it's called MEAN. So let's let MATLAB compute the mean, and it better come out to be 0.4888, right? So we'll do mean of V, okay? 0.4888, okay. Now what about standard deviation? Suppose you don't know standard deviation. So you go over to the documentation, and you put in, say, standard deviate. There, I see it right over here, right? Standard deviation, STD, okay? So let's, we're going to just, I should be able to click on these things. Okay, let's see if that, yeah, standard deviation, okay. And it gives you the documentation. Can everybody see that? I can blow it up if you want, okay? So, and it gives you different types of ways of doing it. It gives you an example for everything. In the first example, standard deviation is called with just one array, and there's no second argument. In the second call, there's two arguments. There's A and W, okay? Now let me tell you, if I just do STD of V, what happens, okay? Remember, I got a standard deviation of what, 0.2831? So if I do the built-in standard deviation of V, I should get 0.2831, but I don't. I get 0.2832, okay? And that's not a round off thing, okay? What happens, if you go back to the description of standard deviation, you'll find out that second argument has the second argument that you have to put in. Let's go back again. Standard. Always, it's always good, to use this standard deviation thing. Okay. Okay, let's go to this thing where we got a second argument over here. Okay, let's see if there's some documentation. There we are. See over here where my arrow is? It says specifies a weighting scheme for any other previous syntaxes. Okay, if you put second argument to 0, which is the default, it's normalized by n-1. Some people, when they calculate standard deviation, don't use n in the denominator, use n-1. I don't know why, I'm not a statistician, okay? I'm used to the n over there. And therefore, you can see when w is equal to 1, if you put the second argument as a 1, it's normalized by the number of observations. That's what we want, okay? And that's why we didn't get the exact value that we had in the program that I wrote, because I did it this way, and that built-in one is using n-1 over there.
The
So
n-1 is for samples for groups less than 60.
And what advantage does it have? Okay.
Who knows?
Okay. So again, my standard deviation, actually let's do format long. Let's place some fun over here. Format long, okay? And I do S1 was my standard deviation, right? And if I use the normal one, STD of V, see, it's quite different. Now, okay, there's my S1 which I calculated. Let's use the standard deviation, hopefully that corresponds to the one that I coded. It would be V comma 1, and that should be the same as the S1 that I have. Okay, and the last digit there is it too, okay? Okay, so again, just kind of a warning that even if it's something that's pretty common, you always want to look at the documentation to make sure things are normalized the same way. This happens more in special functions, where there's, some people, like if you did anything with Fourier transforms, okay, in signal processing, some people use a 1 over 2 pi, some people use a square root of 2 pi, okay? So you have to be careful about that. Okay. Okay, now this is going to be, next one's going to be interesting. What I'm going to do is I'm going to show you how to use MATLAB to get roots of transcendental functions. Let's look at the function f of x, which is e to the x minus x squared, okay? I want to find a root of that, okay? Well, the first thing you want to do is let's plot it, okay? Let's plot e to the x and x squared with the same set of axes. and then we'll get an estimate of where the root is. The reason you have to do that is because for polynomials, there are algorithms that will get the roots numerically, okay, without you supplying a starting value. But what happens is when it comes to these are called transcendental equations, okay? When you have things with trig functions or exponentials plus algebraic stuff, okay, there's no way of solving them in closed form. And many times they have multiple roots. Matter of fact, when you take vibrations, okay, you get typically for like things like vibrations of beams and plates, you get these weird transcendental equations whose roots are the natural frequencies. And we know that a system just doesn't have one natural frequency, okay? So there's an example where you have to basically, there's an infinite number of roots to this equation, and you have to give some information to the program about what root you want. And the way it does it is you give it an estimate of the closest, you give it a number close to the root that you desire. You have to be very careful. Will it converge to that root? Will it go and get the other root? That's a whole new area in numerical analysis, which we won't get into. But this function will be very simple, so let's just plot it up, okay? Let me go from -1 to +1, okay? Because I think there's a root over there. Clean space. Everybody can see what I'm doing, right? Clean space, -1 to 1. And you know what that does, right? X is now a vector of 100, goes from -1 to 1 exactly, okay? Now let's look at a plot. Okay, what are those two functions I want to do? I want to see when, I want f of x equals 0. So I want to see when does e to the x intersect x squared. So let me plot e to the x and x squared, okay? So first let me do x versus the exponential of x, okay? That's a built-in. And this thing, as I mentioned before, is vectorized. That is, the exp function in MATLAB, when it takes a vector, it interprets that you want to do the exponential of every entry in x. And for graphics, exactly what we want to do, right? We got x marching from -1 to +1. We're going to do e to the x on every component. Okay, then let's plot x against x squared. And again, I have to be very careful, x dot squared, right? Again, because I can't multiply x as a vector of like 100 by 1, I can't multiply 100 by 1 by 100 by 1, right? So doing the x dot squared tells me take every element and square it. Okay, let's see what the plot looks like. Should pop up here soon. Okay, everybody can see that. Okay, and remember the MATLAB default, you can tell obviously the first, where's the one that goes through 0, 1? Okay, so I guess that's the exponential function. No, that's the parabola. X squared from -1 to +1, and there's the exponential, okay? And they intersect kind of where my cursor is over there at around -0.7, right? And actually that's the only root for this thing. If you go over there, that's, you see that one's gonna go up, right? And the blue curve's gonna go down, and to the right of the intersection, the blue is above the red. So there's only one intersection over there, and that's the root that we want, okay? So suppose that I wasn't here and you had this problem of finding the root of an equation, what do? Okay? Okay, if you had maybe like a reference book in MATLAB, maybe you could find it in the index, but if all you have basically is your program, you're on a plane or something, and this is all you got, you can say, okay, what would a normal person call that? Root, right? A root of a function. Okay, so let's do root. Okay? And notice, all I did was root, and the first thing comes up with polynomial roots. I don't want that. It's not a polynomial. Square root? No. Root of a nonlinear function. That's what I want, f of 0. So you click on f0, and it'll give you information on it. Okay? Root of a nonlinear function. Okay? And they even give you an example. Okay? And there are various forms that you can use. We're going to use the first form over there. Okay? Everybody can see that. Okay? What happens is the name of the function is f0, and it's going to have two arguments. One is what's called in MATLAB a handle. You need a function, obviously. What are you trying to drive to 0? So obviously we have to code up e to the x minus x squared. MATLAB doesn't know that's what you want to find the root of, right? So clearly we have to write a routine that basically calculates, given any x, e to the x minus x squared. Well, that's easy enough. We'll look at that. And then the second argument to f0 is your estimate of the root, okay? And you try to get the one from the graph that's closest to that, okay? And you'll see that it'll zero in on the exact root. I should say exact root because you can't calculate the root, but it'll get it to like 6 or 8 decimal places, which is good enough for engineering practice, right? Okay. And there are all types of other things you can do. There's another thing, sometimes you'll want to bracket the root, okay? We know by simple continuity, right? If a function f of x is negative at one point and positive another point, there's a 0 in between there. So in addition to giving a starting value for the root search, you can also give it an interval where it changes sign, and then it's guaranteed to converge to the root. Okay. So let's look at this function now that's going to get, what did I call it? I need a function that basically gets the 0 of the root. What did I call it? I'll call it trec.f for transcendental equation. Okay, let me open that guy up. Okay, look how small this program is. All it's going to do is, given some x values, calculate e to the x minus x squared. That's the function that you want to drive to 0. So again, look at the syntax very carefully. It's a function program, okay? And this is basically, you have to do it this way because that's the way, if you look at the documentation of the function f0, which is the workhorse of this thing, that's what MATLAB uses to find the root, you have to write a function that calculates the function f that you want to drive to 0. And the input is, again, very specific, okay? The name, you can put anything that you want, okay? Call it trec, call it test, it doesn't make a difference, okay? But it has one input argument, x, okay? Now, normally you would say, oh, why not just have e to the x minus x squared? Why do I have a dot over there, okay? The reason for that is that because MATLAB is very efficient. And instead of calling this function that you want to drive to 0 over and over again with this value of x and that value of x, that value of x, it basically looks at kind of where the function is changing, whatever, and it basically come in with a vector of x, maybe like 10 values, okay? And what it wants to do is go in there once and calculate the function f at those 10 values all at once, okay? So therefore, you have to write this in what's called a vectorized form. And the documentation tells you very carefully about that you have to do that. And if you look at the examples, again, you'll see that, okay? So here we come in now. Think of x now not as a scalar, but as a vector of values, okay? And what we want to do is calculate e to the x minus x squared for all those elements in the vector x. Well, the e to the x, it's already vectorized in the sense that MATLAB, the exponential function, if you give it a vector, it'll give you e to the x1, e to the x2, e to the x3, which is fine, right? So you have a vector here, and what is that vector? It's the exponential of all the x values, okay? And what you're going to subtract from that is the square of every element in x. Hence, again, the dot before there. As a matter of fact, you can put the dot over there, you get an error message.